So to moderate the next session, can I welcome Darren Davies, who's the Communication Manager of Stakeholder Engagement. Is this the right one? Yes. At Cotton Australia. And his role takes in media relations and grower communication, which is why you saw him with a camera at lunchtime. I've been really looking forward to this session. It's a new addition to our program and we've got some really exciting speakers lined up. So please come up, the innovation people, come and take a seat on the stage and we'll get this session going.
Thank you, Brooke. Okay.
Yep.
I wonder how the energy levels are going after lunch. Hopefully you've got some energy left for us because this is going to be a rather fascinating session. Now, there's no doubt, as you know, that technology and innovation are a huge part of the Australian cotton industry. Now, that's underpinned, as you've already heard today and you'll hear more of, by the significant ongoing annual investment in research and development. Now, as you probably know, because many of you have visited cotton farms, I hope, and those who haven't, I hope you get to soon, most of our farmers are researchers in their own way because they're trying new ways of growing cotton in the field. You know, they tinker with their machinery, as you know about, to make it more efficient, of course, and to see what it can do and what the scope and what they can get out of their machines, but also finding new ways to drive sustainability in their own paddocks, their own fields. And then they share that knowledge. Today, we will hear from three very different innovators in the Australian cotton industry, from blue sky research that could be decades in the making to technology that's being used right now on farm. So we'll first hear a short 10-minute presentation from each of our innovators, and then we'll open the floor to questions. So as you're hearing each presentation, think of those questions. I'm sure there'll be plenty of questions. Now, to start things off, can I introduce Dr. Xiaoqing Li, who is a research scientist at the CSIRO based in Canberra. Now, she joined the cotton fibre quality team in 2020, where she focused on developing novel cotton fibres through genetic engineering. In 2022, Xiaoqing led the Traceable Cotton Fibres project, awarded under the Science and Innovation Awards for young people in agriculture, fisheries and forestry. Please welcome Xiaoqing. Yep.
Button. Okay. Hello everyone, I'm Xiaoqing from CSIRO, and thanks to the organizer for giving me this opportunity. Also thanks for the introduction, and thanks for the previous presentation, because from that we all know that in the textile industry we are facing a problem, and the problem is how to track the cotton fibers properly. And that's what I'm going to talk about today. So many of you may know more about how complex is the textile supply chain is. And it's very difficult to actually track the fiber from the original source to its journey until it's become a product. And data is increasingly needed for prove the sustainability claims. So that's why fiber traceability is important and much needed. And what we are trying to do in this project is trying to find exploring other new way to do fiber traceability. And fiber traceability is always in our focus for developing more sustainable fibers. But we actually start to work on that since 2022, when the CRDC ABARE Science and Innovation Award was granted to us. Okay. So as we know, today's customers are more mindful of choosing products that are made from more environmentally or socially responsible materials and process. Also for the companies, they would like to improve their sustainability and also want to provide proof for their sustainability claims. But it's actually really hard to provide those data without proper fiber traceability. And Australian cotton is a very good example because it has high quality. Also, it has one of the highest social and environmental standards during the process and production. But the customers actually has higher sustainability needs. Will favor it with these kind of products. But how to track them properly? So currently in the market, there are lots of technology has already been developed. And here are these. For the first one is trying to keep the records properly. And that involving this blockchain system and the softwares are used in this one. However, because these involve in multiple countries and regions, also there are different cultures and languages involved, so it's quite challenging sometimes. There's also other options to use exogenous markers, for example, adding the pigments or DNA markers. These are very good. However, it's needed to add additional steps for this process. And the third method is based on some plant-based material. For example, have the testing the DNA existing there, and we can tell what type of the cotton is. For example, is it Pima cotton or Egyptian cotton? Or we can also test the isotope composition and to tell which farm it has been grown. But the problem is when the fibers get mixed together or when the concentration is getting very low, it can be quite challenging. So what we are trying to do is also a plant-based method, but we would like to have the plant to have the markers embedded in the plant material already, and that would be really good if we can have that. Before we start to work on fiber traceability, we were working on one of the CSIRO Future Science Platform project, which was aiming to develop a gene and foreign protein toolbox, which can generate novel cotton fibers with additional functionalities. And one of the fiber we're trying to make is colored fiber. And we introduced a new gene into the cotton fiber, which was a colored protein and also fluorescent for this protein. Unfortunately, we didn't able to see any color in the fiber, but we do able to detect the fluorescence from the immature fiber. In one of our lab tour, when Mr. Cliff Rogan was visiting us, and he inspired us by saying, well, such fiber could be used for fiber traceability. And then I applied for the CRDC and ABER's Science Award, which was luckily granted in 2022. That's when we start to work on this. And we hope this kind of material can be able to used for developing some simple and cost-effective plant-based method for fiber traceability. And as the development, it's just like the development of new technology for many things. The first start was not very successful because we got promising result from detecting the fluorescence from immature fiber. We thought this one will be a simple start to detect the fluorescence from the mature fiber. However, it wasn't very successful because the autofluorescence from the mature fiber can be very strong, and we can't tell much difference from the transgenic cotton fiber or the normal fiber. And then we were thinking maybe a FTIR scan can give us a different fingerprints between normal fiber and this transgenic fiber. However, they look exactly the same because FTIR scan we thought is based on the chemical structure. They could be different, but there's no much hope from there. And luckily, we're trying more methods. The method we're trying to do is directly detect the protein inside the cotton fiber, which was successful. And the first one was trying to use the LC-MS system, which is a very powerful system used for proteomics to identify and measure the protein. And even the system we haven't optimized it at all, just try to use a basic one, and we were able to detect the protein in the mature fiber when the protein concentration is relatively high enough. And then another method we think has huge potential is the antibody-based protein detection. This is a bit like the RAP test for the COVID-19 virus infection. So it's based on antibody, and the antibody is actually very specific to the target protein. And with this method, we were able to achieve quite a good detection limit to as low as 0.2 milligram dry mature fibers, which was quite good. Okay, and then based on all these experiments and results we have, we think there's actually further potential to increase the sensitivity for detecting those proteins, including both the proteomics method and the antibody-based methods. And then another part is for the fluorescence detection. Although our first attempt was failed, but we think there's still other possibility to amplify the signal inside the fiber, and then we could be able to detect it potentially. And on the other hand, although we tested the fiber which have been harvested from a mature cotton ball and which was successful for detecting those proteins, but we haven't tested anything afterwards in a supply chain or after all those different processes, what's going to happen for those methods? Is that still going to be work? It's worth validate that. And also for another part is having this GM marker or GM traits embedded into the cotton has its advantage for fiber traceability. However, releasing a GM variety is quite expensive and lengthy. So the option we could have is possible we can embed this GM traits along with the other already developed GM traits together, which might save the cost and time. Or alternatively, if we can find something already existed in a native cotton, which is non-GM, if we can identify them and based on different regions or sources, and that will be even better. Okay, so our dream is in the future, we can easily trace the materials from the final product by simply scan them, by combining all this technology together, and then you just scan them, and possibly all this traceable information, key information will just automatically pop up for us. That would be fantastic. Okay, that's basically the most important part for my presentation. And I've got another important part is about technology for those people who have already contributed and inspired, also helped with this work. And also thanks for the CSIRO Future Science Platform and the CRDC and ABERS for their support for our project. And finally, thank you for your attention.
Thank you, Xiaoqing. Next, we have Dr. Guy Roth, who's been an integral part of the cotton industry for over 2 decades, having worked as a cotton scientist at CRDC and as head of the Cotton Cooperative Research Centre. Guy now runs the University of Queensland farm in Narrabri, which grows many crops, including cotton. The farm is MyBMP certified and is used for in-field student and industry research. Please welcome Guy.
Thanks, Darren. Yep, there's a picture of some of our students hard at work there, and I've spent most of my career on soils and water, but the other important aspect of natural resource management is biodiversity, and I can sense that this room knows it's important, but the real problem in a way, or the challenge, is how to measure it, monitor it and report it, because biodiversity is very diverse. You can tell I'm a rocket scientist. All right, well, welcome to the University of Sydney's largest campus, not the one just up the road. Our campus would extend from here, this lectern, to the Olympic Park. So we've got roughly 5,000 acres and looks like that. We do grow cotton, and you can see we've got some trials here. These were CSIRO trials. We also grow other crops. And 7 years ago, we started growing cotton, and we've now got our MyBMP accreditation, which we're very proud of. We also grow lots of other crops, mostly wheat, canola, chickpeas, fava beans, lentils, and pretty much any other crop, barley, oats, hemp. So we've got quite a diverse, we grow roughly 20,000 of that whoop plots. But part of our farm, the other 500 hectares, is sort of this sort of more natural resource area. These are poplar box trees, and we've had a wet season, so what you see in northern New South Wales are darling lilies like that. They pop up in the pasture. So just giving you a few pickies of what the area looks like. And our core business is teaching and research, and our students come up to Narrabri and like to get dirty in the soil, and here they are doing some pracks and things. Biodiversity is important because of the Sustainable Development Goals, number 15, life on the land, and also the Task Force on Nature-related Financial Disclosures, and how do you report to and participate in these sort of frameworks. So the traditional way of monitoring biodiversity is to go out and do it. And the problem with that is you have to be an expert in birds, insects, plants, soils, animals. Not too many people are experts in all these areas, and so we teach our students, and here's an example of 7 or 8 of them, none of which have actually had farm backgrounds, have spent some time learning the old-fashioned way. ground-based surveys, which are very time-consuming. Now, I've just spent 5 years every quarter for 1 week getting up at sunrise, probably, which is the best time to monitor birds. So we do winter, spring, summer, and whatever other season I missed there. 5 years every quarter at sunrise, and we've found on our farm, just our little farm, 140 unique bird species. That just blows your mind. That is a lot of diversity in terms of species, and how that changed through the drought, and the birds are recovered and things. So that's the old way of doing things, and very interesting work it was. But it was time to introduce some technology, and that's cameras and sensors and acoustics. So we put these sensors out around the farm. So there's a camera. I've got some here. I left them in my bag. They're out there under the table. There's a camera and a sensor there. You can see a sensor there with a little microphone. So that's listening to the forest or listening to the crop. And the camera, anytime something goes past, it takes a picky. And we found something we did not know, 15 species of these bats, 5 of which are threatened species on our farm. We didn't know they were there. And why, as a cotton farmer, are you interested in bats? Because they eat insects, and insects are the #1 pest of crops. So that's called an ecosystem service. And that was fascinating to us, particularly a couple of these are threatened species. So, and one of the reasons we didn't find them is because we go to work somewhere between 6 a.m. and 6 p.m. where there are no bats. They come out at night time, and particularly around midnight. And so, but the sensors can do that. It's a bit like if you knock off the Commonwealth Bank tonight, they'll have sensors monitoring it. So, and look, 1,500 findings, so that's a lot of data. The other thing we've been doing is tracking, this is like Life 360, tracking the feral pigs on the property. And so we put a collar on them with a GPS, and you can, well, the different pigs have different colours, and we can see how they've moved around the farm over 12 months. And this is an example of some pigs that have come out of the forest, come down the creek and visited our farm, eaten our fava beans and then gone home. But most of them are living locally on the farm, and that was the key learning that we weren't really sure about, and landholders weren't sure. Most of them actually living on your own property if you've got water and food, which we do in terms of crops. So but we're able to track these things now. That's all I'm really trying to point out. Then we get to environmental DNA, and this is the really exciting part because we all shed DNA, humans, animals, doesn't matter what it is. So we can either use a paint roller and rub it up and down a tree or something to get the DNA, to be like the detectives coming here to the Commonwealth Bank tonight after you knocked it off, they'll rub it down and pick up your DNA. Or you can just monitor it in the air by leaving a sensor there and sort of go through those cones there onto some cotton wool, and then we can send it off to the lab and get the DNA footprint. And or you can put it on a drone and fly it around the farm and collect thousands and thousands and thousands of pieces of data at scale, because that's where we need to do this, at scale. And then using Amazon's sort of web-based platform and artificial intelligence to process all this data, you end up with a lot of data. And you can see over time some examples there of lots of different species and how they change over time. You can click on a plot, for example, of any number of species and produce a heat map of your farm, for example, of where this particular species are. This is an image of a glass, because we all know what they are, but you can see they pretty much cover all over the property here. But it's really an example of incredible, powerful information. And we've found like in the order of 700 species or more on the property, and using these technologies, it's getting easier, faster, and less skillful in a way. And we've all heard about the challenge of labour and that sort of thing. So this is what we call our biodiversity challenge, and using a lot of different types of technology. And really, to sum up, our aim is to really develop business-ready solutions using AI, machine learning, remote sensing technologies to enable this biodiversity monitoring at scale, at a sort of a farm scale or a catchment scale. And we've set ourselves a goal at the University of Narrabri, as we call it, to increase biodiversity, not maintain it, to increase it and our carbon, and really understand natural capital's role in making us as better farmers, better researchers, and also better educators. So thank you.
Thanks, Guy. I reckon you could talk about that for hours, couldn't you?
We could.
And I'm not sure a scan after hours at the Commonwealth Bank will find too many endangered species either, Guy, but maybe there are a few. Lastly, can I please welcome Jason McNeice? Now, Jason has a long history in the tech space, including in software, IT, data and digital products to support farmers and agriculture. His most recent role is Field Operations Manager for SwarmFarm Robotics, which is a company that started in Emerald, Central Queensland, and is designing, building and implementing technology in the field that really is changing the face of agriculture. Welcome, Jason.
Thank you. Could I have the... here we go. All right. SwarmFarm Robotics. We are a company that is changing the face of agriculture. Thank you. Literally and figuratively, our robots are becoming and are part of the family on many farms. You know, they are referred to affectionately by the names that the family gives them. And had a lovely moment the other week where the owners and the kids and the grandparents, you know, 3 generations came in to have a photo with their robot as it was getting ready to go out to their farm. Here, this one, its name is Juliet. Juliet works out on the farm at Gindi, where SwarmFarm was first founded. And the job that Juliet does is it goes out and takes camera sprayers, the spot spray technology, and goes over the farm many, many times and sprays the weeds. It's got sensors that will see green on brown, and it just works all day, all night. So this is a picture of where the rest of our robots are, and I took this screenshot at about 1 o'clock in the morning. And you can see that there were still many robots in the coloured dots that were working at that time. Now, we've had a pretty windy couple of weeks, and these robots were, you know, right in the proper window of weather and wind direction, wind speed, humidity, and all those things to be operating, and they just did. And by removing the time constraints that human operators bring to operations on the farm, such as spraying, we can ensure that there's a quality job that's being done by going slower, by you know, getting in the right time window, and by you know, starting and stopping when it needs to for the weather and all of that sort of thing. These swarm bots are helping farmers spend more time with their family or on tasks that are higher value rather than sitting on a spray rig. And if any of you have you know, sat there and done spot spraying, it's a slow old process, and it actually gets done better by going slower. Not only this, they are a platform to bring technology to agriculture. So here we've got a picture of just a small selection of the implements and attachments that can be attached and integrated with the robot. And we have spot spraying, blanket spraying, mowing, spreading, and soil measurement. So there's some robots out there with EM38 surveys, you know, 'cause that's another one that our agronomist friends will love not doing. You know, one of the real exciting things about this is that when there's a new technology that is ready to go to farms, but but needs like connectivity, and it needs particular speed and a way of operating that doesn't currently match with human operators, they can integrate with our robots and launch on farms. So how does that apply to cotton? This is a picture of a robot that's operating in dryland cotton. It's doing in-crop weed control for better moisture availability. What it's doing there is a camera that is located over the row in between the cotton, and it's spraying weeds as it sees them, and not spraying the actual cotton itself. We also have a number of robots working in cotton irrigation, and that has brought along a number of features that are specific to cotton and the way that cotton farms are. And this photo is of a robot that is operating in a cotton field, and many people believe that autonomy starts with going up and back. When you bring in irrigation systems, there's a lot more obstacles, and this robot is going to turn around at the end. It'll lift up above the head ditch or the gates or the irrigation infrastructure, and it knows where that is. It can perceive it also, and operate on the farm and integrate with the implements in a way that gets the job done, in a highly technical way. So there's a number of benefits to utilising robotics for farming, and the number one sort of big win is chemical reduction. So, not just through the spot spraying technology, which gives us, very large amount of savings, probably, up to 80–85% savings on chemical usage, but also being able to do the job much better, to be able to do it in the right windows when humans are asleep and when the weather is right, and only where it's needed. And that's really key is if there's a weed there and it gets sprayed, the areas that don't need to be sprayed or don't have that weed don't get sprayed. Soil health is also another benefit from having smaller, lighter machines. It allows the soil structure to regenerate. They stay on the same path each time they go around the field, so that it's not compacting the plant growth area. And it allows the microbes to regenerate because it's not spraying the whole lot of the field. And then the last one, which is really important, is weed control. So we have a problem with weeds becoming resistant, but when the robot is able to go and spray at times where it's inconvenient to humans, they're able to get the weeds at a smaller or more vulnerable stage, and by going over more times, which is a time drain on us, it's able to get them before they become either resistant or large enough that they become more resilient. So the benefits are measurable, and through having robots in the field that are connected, they are making thousands and thousands of measurements on many different things, from the rate of the spray to the diesel that they're using to the chemical that they're putting out and the hectares that they're working. There are measurable savings. And so in the last 2.5 years, we have farmed 1.6 million hectares. We have saved 3.5 million litres of chemical and 500,000 litres of fuel. And we're on track to do that same amount of savings just in the next 12 months. So by the end of 2025, we will be on track. And there are robots that have done over 10,000 hours. They are out in the field working and working well. I just wanted to share with you, my passion for the sustainable productivity that can be achieved through robotic agriculture. And thank you for your time.
Thank you, Jason. That leaves us with 10 minutes for questions. 3 fascinating speakers on totally different subjects. So where can we start? Who has got a question for who? Who's going to start us?
I've just got a comment while someone else comes in with a question. I was at a dinner a month ago and down in Gunnedah, a grower dinner, and a grower that I know was sitting beside me and he pulled out his iPad and I said, "What are you doing?" He said, "Oh, I've just sent the robot over to my neighbour's place to do some spraying. I'm just checking." He was 150 kilometres away, his robot, and he could go to the dinner that night and celebrate the year with all his friends, and his robot, he was just watching to make sure it was going all right.
Yeah, brilliant, brilliant. Yep. We're enabling farmers to spend more time with their families is a pretty important thing.
Anyone got any questions? Thank you.
Thanks. Question for Guy. You showed like quite a range of different technologies for monitoring, and it seems like you got such a comprehensive picture because you used everything. You kind of just threw everything at it. In terms of kind of bang for buck, like what would you pick as the most like cost-effective
Yep.
option?
Well, just before I answer the question, I noticed there's 2 Sydney Uni students here running the microphone. I'd like to just thank Cotton Australia for providing them the opportunity because they're volunteering their time in their uni holidays. Annalise and Coco.
Thank you.
And I'm sure they'd be interested in hearing from any of you out there who might have some opportunities. Now, back to the question, the bang for the buck. That's the purpose of the research is really to try and explore out which ones work and which ones don't. And in a way, it's horses for courses. Some of them they've got pros and cons. And it also might depend which species you're chasing. Like obviously the acoustic sensors are going to work best for bats because they're out at night time in the dark, or an owl or something like that. Whereas a feral pig, a camera, or probably a thermal infrared image. I didn't show that, a camera, a thermal infrared measuring the heat, that sort of thing. So I don't think there is going to be any magic bullet. I think it really depends on what your objective is. But it's really at the end of the day, which I think your question's alluding to, being able to do it cost effectively and at scale. And I think in the end you're going to use some sort of focal species because there's just so many species of the environment. You're just going to pick a couple of focal species. Now we started with birds, for example. They're a good focal species. Farmers can relate to them. They know what they are, and certain types of birds indicate certain types of habitat and that sort of thing. So that's just one example, yeah.
Anybody got a further question? Thank you.
I've got a question for Guy. Firstly, we don't hold any money in this site, so don't try and rob it, please.
I thought it'd be under the stage.
Sorry to disappoint. My question is, on your farm, given it's such a diverse range of birds, bats and everything else, are you seeing a direct impact in upside or yield or benefit for the cotton that's being grown there?
That's the next step. We've done a little bit of work on that, and that's where we'd like to go next. So how far for example, are the bats venturing out into the cropping paddocks and vice versa? So we've definitely got some evidence of that, but we'd like to do more. And that's sort of what's next, really.
Hi, another question for Guy. Sorry. I was just wondering whether you've connected with Dr. Debbie Saunders of Nature Helm and Wildlife Drones, who's already commercialised some aspects of what you've talked through.
I'm obviously presenting on, you saw the big list of names there. We have some connections with other universities and other organisations, but there's quite a lot of activity in this space, yeah.
You've got a question here?
Yeah. So obviously there's a lot of brands and retailers in the room, including myself, and a lot of the time there's conversation about collaboration between industry, researchers, brands. So is there anything that any of the three of you would like to kind of communicate to us as brands that we need to know, or how we can collaborate better with the innovation and research that's happening. That's just incredible. But how do we kind of better collaborate between those two groups?
Would you like to go? Would you like me to?
You can go first.
I'll go first, but you two definitely have to answer. We would love to collaborate more with, particularly, that's the whole reason I came down here. To be honest, in that last slide, we had this vision, if you like, and we're really interested in collaborating with companies like yourselves from a teaching perspective. The University of Sydney is about to require its fourth-year ag students to spend a significant amount of time in Narrabri, so from a teaching perspective, but also a research perspective. And in the case of biodiversity, we've got on that map, we'd like to plant 100 hectares of trees. And so we're trying to work out how we're going to fiscally do that. And yeah, so that's the answer.
I can go second. So actually, I've been working in the cotton research for about 5 years now. So I think I was in a very good team, which we have Colleen over there, and she's doing actually a fantastic job about collaborating between different brands and different other stakeholders, including researchers or some other designers and the government everywhere. So she actually connects very well with them. But I think as a normal researcher as me, I wasn't so engaged in the beginning. I mean, before I started in the cotton industry working with Colin, I found we actually need to be quite open-minded. And normally in the past, I wouldn't think I would talk to a designer before in my life, because I thought I was just focusing on work in the lab. I think that's one thing. So you have to be open-minded and believe, or we have to listen to each other. So we actually have given the time to engage with some other people, either consumer, for example, and the brand people. They come to talk to us what they would like to have. But also for the brand people, I think for them, sometimes they don't have a very, the reasonable anticipation or expectation. They would like something very fast and fantastically, but we can't do that. But I think it's really good to have the conversation first. And sometimes maybe we can do it, but maybe on the organization level, we are not matching very well. So it's very difficult, I think, but at least we have to be open-minded on both sides and then start to connect first. And I think Colleen is one of the best examples for doing this kind of thing. Yeah.
And also, Jason, with yourself too, I'd imagine that with those figures that you showed everybody around sustainability and gains, improvements, that collaboration would be welcome from your perspective as well.
Yeah, absolutely. You know, I don't think yet many of our farmers are telling the story about how they're, you know, doing these savings and creating, you know, better farming or more sustainable practices. And I think that's something that could be collaborated on. Yeah.
Okay, we've got one more question.
Hi, thank you. Thank you, Guy, for your presentation. This is directed towards you. You mentioned planting trees just before. Is Sydney Uni or your specific area looking at biodiversity credits and carbon credit units at all? And what's your view on that?
The shorter answer is we're looking into it. It's quite complicated, as you heard this morning, particularly the carbon projects and biodiversity projects, but that's why we're wanting to go forward with this, some tree planting and work like that. We're like other landholders that just, we're looking at it. You have to look at the return on investment and other metrics around that, and that's really where we're at.
Zara, you've got a question.
I did. Am I allowed to ask one?
You are.
Great. Jason, for your knowledge, Calibre is our newest family member, and very lovely to see the robot run around the farm, except when it holds me up getting to the school bus and it doesn't realise I'm quite behind it just yet. But I can absolutely attest, and my husband would be terrible at telling the story about why they've got it, but it allows that really efficient job. He can do other things and sometimes even pick the kids up from the bus as he's doing this afternoon. So it is a great addition to our family in that sense. But my question was from Guy, sorry. I'm so interested in the scale. How are we thinking catchment scale? We're thinking multiple farms could rapidly do some of this biodiversity assessment because we know there's good stuff out there, we talk about it, but we've got to get the data and the evidence to support it. And that real hand-on field measurement is so expensive, but also not something that every farmer can get out and do. And then you want it to be a little bit independent too, to be really backed up in the public domain. So what scale do you think it could be applied to?
The best scale, the easiest would be get half a dozen, 20 farms are up some valley or in some sort of little catchment area or a group, rather than the whole Namoy Valley, for example. Or if you're a large corporate, a big farm up in the Northern Territory or somewhere where you might have 50,000, 100,000 hectares, and that's a sort of scale, yeah.
All right, that's it for this session. Can you thank our innovators? Thank you.
Thank you.